Welcome everyone. My name is Trevor Dyke. I'm a product manager at AWS, and I've been working with AWS's messaging and workflow services for the past almost 3 years. And recently I've been focused on a new service, which we're going to talk about today, which is Amazon MQ. And joining me today is Amulya Sharma from the engineering team at GE. So let's just talk a bit about enterprise messaging. And it's been around nearly as long as computing itself. It's what allows different software systems written in different languages on different platforms and sometimes in different locations to communicate and exchange information. SQS was actually the first AWS service launched in beta in 2004. And it's extremely highly used and successful messaging service. And SQS was designed to be extremely scalable and simple. So as an example, Amazon.com's e-commerce platform relies on Amazon SQS for every single order. And one of the numbers we like to share is that recently on Black Friday, we managed up to 40 billion messages, and that's just in one of our regions, at a peak of 14 million transactions per second. So those are, some existing messaging services we have in AWS, but they were built for applications that are born in the cloud. So they don't need all the features to interoperate with on-prem and legacy applications. That's why they're super simple and infinitely scalable, and they're fully managed, so there's no heavy lifting. But if you want to use them with existing systems and built on industry standards, you have to rewrite a lot of your applications, and that can be large. For large companies, that can be sometimes hundreds of applications. The standards-based messaging systems that customers are using today, you've told us they're time-consuming and costly to manage. And the actual word we heard customers tell us is that they're painful to operate. Setting up a message broker on-prem requires procuring, installing, configuring new hardware, as well as architecting your system for failures. And that's why some of our customers have moved their message broker to EC2 rather than provisioning their own infrastructure. But they're still stuck with managing the message broker. Dealing with software and security setup, ongoing upgrades and updates, it adds a lot of operational overhead and really no business value. And commercial message brokers have that added overhead of expensive and cumbersome licensing commitments as well. But many mission critical applications rely on messaging, so constantly messing with these systems and maintaining uptime can be quite scary. So at our recent reInvent conference in November last year, we launched Amazon MQ. It's a new service we built for you guys that gives you messaging compatibility without the overhead. A simple analogy for this service is you can think of it as a system very much like RDS, but for message brokers. So Amazon MQ automates a lot of the time-consuming tasks of operating message brokers. Things like managing servers and storage and other hardware such as networking equipment. Managing reliability. It turns out it's quite challenging to run a messaging cluster with high availability and durability. You need to have a team of experts to run your messaging servers, and we take that overhead away from you. Setting up and provisioning new message brokers can be timely, and with Amazon MQ, it just takes a few clicks and a few minutes. Maintenance, such as software upgrades and security updates, monitoring the health of your broker and the infrastructure that sits underneath it, and any troubleshooting is taken care of by AWS instead of your own team. So we talked about what drove us to build this for you. You told us you wanted API compatibility, both to make it easier to migrate and to provide interoperability. So we looked at what was out there, and we built this using a really great open source product, which is Apache ActiveMQ. It's compatible with industry standard messaging APIs and protocols, which enable you to migrate applications to AWS without rewriting code. So most importantly, there's JMS, Java Message Service, and it's the native API for most message brokers. There's also NMS, which is a .NET version for those .NET apps that you want to migrate. And the new kid on the block is AMQP, or Advanced Message Queuing Protocol, and it's recently been ratified as an ISO standard, and it's gaining popularity because it offers compatibility at the wire level. It also includes some nice protocols like MQTT, which is popular in the IoT space, as well as Stomp and WebSocket. So you have a nice choice of APIs and protocols, and these make it easy for you to migrate over from whatever you might be using today to a managed service. One of our partners was Cedrus, and they're part of our beta program as we designed Amazon MQ. They're a New York-based consulting firm, and they worked with a lot of financial companies running on some of the popular message brokers out there, like IBM MQ. And using a beta, recently they successfully migrated one of their customers' applications to Amazon MQ in about a day. So that API compatibility is really important for enabling easy migration. Of course, you told us that we can't lose your messages as well, and we have to provide the high availability required for your mission critical applications. So we built Amazon MQ to automatically provision the broker for high availability and durability. We have an active standby model across availability zones. So in the case of an issue with the broker, or even a full AZ outage, the standby broker simply takes over. And those brokers are using a shared, highly durable message store that's replicated across multiple availability zones. So the standby broker just takes over and all those messages are available, and your application can continue running with those messages and nothing's lost. And like RDS does, we also offer single instances that customers can use for development and test, or just to try the service out. He also told us it has to be secure, and you wanted worry-free security. So we designed Amazon MQ for the security that enterprises need today. Your data is encrypted in transit, of course, using TLS. You can also have your data persisted to encrypted message store. So if you've turned on persistent mode, we also support a non-persistent mode, but in persistent mode, your data is persisted to the message store and it's always encrypted. Today that's using AWS keys. In the future, we'll add the ability to add your own keys as well. It's fully integrated with Amazon VPC, Virtual Private Cloud, so you can block public internet access. Of course, you can have a public endpoint too if you want, but it's common to restrict your broker to within your VPC. And security groups provide further guards against any unwanted access, and they act as a virtual firewall for your broker instance and allow you to control inbound and outbound traffic. There's also settings you can set on queue and topic access, so policies, so you can enable can manage who's allowed to access particular queues or topics for sending or receiving messages, or both. He also told us ActiveMQ is really great, but it lacks some monitoring capabilities. So we integrated Amazon MQ with CloudWatch, so you can monitor the health of your broker. You can monitor metrics such as CPU utilization, memory utilization on the broker. You can also monitor metrics on queues and topics, such as the depth of the queue or the number of subscribers on a topic. And of course, you can use the built-in features of CloudWatch to set alarms to notify you when something goes wrong. And that leverages SNS to notify you by email, or you can have a mobile notification sent to you. You can also use auto-scaling to scale your consumer fleet based on queue metrics, such as queue depth. So that's a really nice feature. If you have queues that are getting full, you can just scale up your consumers to consume those messages more quickly. ActiveMQ itself is a very rich message broker with an active open source community. It supports all the key features required to migrate from your existing message broker to a managed service. So in addition to persistent messaging for high availability, some of you guys really want to crank the performance so you can use transient messaging for where the messages are stored in memory. It also supports transactions with commit and rollback functionality to integrate with your transactional databases. And of course, all the basics are supported, like queues and topics with ordered messaging and once-only delivery. And some of you guys are really using large messages on your enterprise systems today, several hundred K, even a few megabytes. And Amazon MQ can handle that too. We don't have any limits on message size. And there's no limits on the retention of messages, so you can keep your messages stored as long as you like. One thing that's really cool is that if you're already using ActiveMQ, perhaps on EC2 or even on-prem, you can just import your XML file to migrate your configuration. So that makes migration really quick. And last but not least, you guys told us that enterprise messaging can get really expensive with licensing, support, maintenance costs, as well as the infrastructure itself. So with Amazon MQ, we make the cost a lot more manageable. Like AWS, like the other AWS services, you only pay for what you use. There's no upfront costs, fees, or licenses. You can get started for free for the first year. We offer, for the first year of your account, you can use what we call a T2 Micro, which is our smaller instance size, for up to 750 hours a month. And that includes 1 gigabyte of storage for messages. And that can be used for up to a year for free. After that, it's only 30 cents per hour for an M4 large instance, or for the T2 Micro, it's 3 cents an hour. And for an HA pair of large instances, it's 60 cents an hour. And storage is priced quite attractively at 30 cents per gigabyte month. So that's for each gigabyte for 1 month, you pay 30 cents. This is US pricing, and the prices may vary slightly by region for outside the US. So now we'll switch to a quick demo. So this is the first time user experience you'll see with Amazon MQ. And what I'm going to do is I'm going to create a broker. I'm going to show you how quick and easy it is to create a broker. Then we're going to show a failover to show you how high availability works. And then we'll show you how CloudWatch metrics work. So let's create a broker. We'll call it My Broker. Then we get to the Create Broker page, and we can select the instance type. As I mentioned, we have 2 instance types today, the T2 Micro size and the M4 large size. So we'll pick a large for this demo. Then we pick the deployment mode, so single broker or active standby for high availability. So we're going to choose active standby because we're going to show you a failover. Then you enter a username and password, and this is so you can control console access. So this is the username and password to access the console. So now you can see my creation is in progress. And it takes about 10 minutes or so for that broker to be up and running. So to speed things up, I've already created a broker that should be ready in a moment here. And then I'm going to show you that broker. Same mode, it's active standby for high availability. So we'll go and take a look at that broker. So you can see here all the details of the broker we've created. There's a ARN, there's the specifications of the broker, showing you the type of instance, deployment mode, and so on. There's the security and network settings, as well as the configuration. And down here you can see all the endpoints for each protocol that we support. So OpenWire is the default. And then we have 2 endpoints for the ActiveMQ web console, one for the active and one for the standby. So we're going to go ahead and take a look at the active broker. So if we click on that URL, we'll see there's our ActiveMQ console. If we click on the standby, you'll see that you get a site can't be reached because that broker is in standby mode. It's not actively running. So we'll go back to the active broker. And we'll select Manage the Broker. We'll enter the username and password that we entered when we created the broker on the first page there. And now we can see we're logged into this broker. You can see some details about it. And we'll go ahead and take a look at the queues. So let's create a queue. Call it My Queue. And we can see there's no messages in this queue, of course. We've just created it. So let's send some messages to this queue. And what we'll do is, first we'll send some messages in non-persistent mode. So if we leave this flag unchecked, we are in non-persistent mode. That means messages are only stored in memory, they're not persisted to disk. So we'll send 100 messages. Okay, we can see those messages are available in that queue, they're pending. There's no consumer, so they'll sit in the queue. And now we'll turn on persistent delivery and we'll send 100 more messages. So now we have 200 messages sitting in that queue. So what we're going to do is we're going to invoke a failover situation. So what we'll do is we'll reboot the broker. What that means is we're going to switch from the active to the standby and then back from the standby to the active again. So this would simulate what would happen in the case of your active broker failed. So this broker is now being rebooted. You can see the reboot is in progress. And I'm going to go take a look at my active broker. It's still alive. In a moment, you'll see that it's going to fail over. So this is the standby broker. Let's go back to the active. Okay, so now we have the standby broker is alive, so we'll log into the standby. And we'll take a look at the queues on the standby broker. And we can see there's 100 messages there. Why only 100? Well, remember we sent 100 in non-persistent mode. So we've lost the 100 in non-persistent mode. The 100 in persistent mode are actually available on the standby broker. Now let's go back to the, the standby is now failed over. So it's going back to the active. So let's go back to the active broker. And now we can see that those 100 messages are there on the active broker. So we failed over once to the standby and then back to the active. And we can see that in action by looking at the CloudWatch metrics. So we just simply go to the broker and click View CloudWatch Metrics. That takes us to the CloudWatch dashboard. We can see we have broker metrics, queue metrics, and topic metrics. So let's go look at the broker level metrics. We have broker 1 and broker 2, and we're going to look at total message count. So we'll look at the total number of messages on the first broker and the second broker being the standby. And we're going to zoom in here to get a little bit more resolution. We'll go to 1 minute period metrics. So now we can see that broker 1, at that time there we had 200 messages, it failed over. We have 100 messages in broker 2, and then back to the active broker and 100 messages there. So that really just shows you how easy it is to monitor your broker, to create a broker, and we show you a little bit about how failover works. So let's talk a little bit about when would you use Amazon MQ and when would you use Amazon SQS and Amazon SNS. So SQS and SNS, as I said, are very highly scalable, resilient, and stable services. We've had them for a long time, and they're going to continue to exist. They're not going away. Amazon MQ is just a new service for different scenarios. So for SQS and SNS, we recommend those for brand new applications that are born in the cloud. And that's because they have extremely simple APIs. They're really easy to learn and use. They provide nearly unlimited throughput. They're extremely scalable. I mentioned some of the numbers that we've seen in Amazon's own business using SQS. And they're a pay per request model. So you just pay for messages that you send on a per request basis. On the other hand, Amazon MQ is designed for application migration. So if you're migrating existing apps that are using an existing message broker, it might be ActiveMQ or it might be some other broker such as IBM MQ or TIBCO EMS or something that's using JMS or one of the standard APIs, that's where we would recommend that you use Amazon MQ because it's API compatible, so it makes migration very easy. It's very feature rich. It supports all of the features that are used by those existing message brokers. And it's a paid per hour and per gigabyte model. So you have your own dedicated broker. You pay by the hour to have those dedicated resources as opposed to SQS and SNS where you pay by the message. So that's really the difference between the services. And we recommend you check them both out and see what's appropriate for your needs. In terms of region availability, it's generally available now in 6 regions, the ones listed here. So 3 in the US, 2 in Europe, and 1 in Asia. We will be rolling out more regions throughout 2018 and into 2019 as well. We have 6 new regions planned for 2018, and more coming in 2019. One of the other things I wanted to mention is you can use Amazon MQ to integrate on-prem and cloud environments. And that's using a feature of ActiveMQ called Network of Brokers. So what you can do is if you have some on-premise applications and you have some applications in the cloud, or you're migrating some applications to the cloud, you can simply deploy, or maybe you already have an on-prem ActiveMQ broker. And using a fairly simple configuration, you can network that with an Amazon MQ broker in the cloud. And that allows you to send messages between your on-prem applications and the cloud-based applications. So in this case, we were showing a producer on-prem and a consumer in the cloud. But it can be the other way as well. You can have a producer in the cloud sending to messages on-prem. So that gives you quite a flexible way to migrate. You can start by migrating a few applications, or maybe you have some applications that are permanently going to remain on-prem. Maybe they're connected to a mainframe or something like that. And this gives you a nice way to do a hybrid kind of integration. Another use case is for modernizing existing applications. So if you have existing applications, again, in your on-prem environment, or maybe they're actually in the cloud, but you're not going to modify those, but you want to connect them to leverage some of the advanced services of AWS. For example, Lambda, maybe some of the analytics applications, through DynamoDB. So you can actually subscribe a Lambda function to monitor your queues on Amazon MQ, and then send that data into DynamoDB as an example. And that gives you access to all the advanced services in AWS, and you can start modernizing some of the applications that you might have in your environment today. So we'll talk a little bit about future direction, and then I'll pass it to my my colleague Amelia from GE to talk about GE and what they're doing with messaging. So in terms of future direction, we can't give you details specifically about the roadmap, but some of the things that are upcoming that we wanted to highlight is, first of all, CloudFormation integration. Obviously very important for a service like this to be able to automate deployment and configuration of your brokers. So that's coming soon. We're also planning to do several things to give you higher performance, so both horizontal and vertical scalability. We're planning additional regions, as I mentioned, and we're also working on getting the needed regulatory compliance for many enterprise environments. And there's a few more things we're working on that you'll find out about as we get closer to launching them. That's all I had for Amazon MQ. I'm going to pass it now to my colleague, Amelia, to talk about GE and messaging.
Thank you, Trevor. That's a good presentation so far. You also covered some of the good use cases, and which are very interesting in general. So let me begin with my section of the presentation. I'm Amulya Sharma, engineer at GE Digital, and I'll share what we are doing with messaging at GE and how does our work related to the Amazon MQ as well. So a little bit about GE. GE is the world's largest digital industrial company. From big iron to big data, big machine, we have all of it. So measuring a performance of a big asset at the edge location, sending it data back to the cloud, measuring, analyze the data and do some decision making and send the decision and operation back to the edge is all about it, basically. So one of the reasons why GE has to build a big data processing engine in the cloud for all of its industrial IoT data is these days customers do not ask simple questions like, hey, give me an asset and give me a service plan on the asset. They ask harder questions like, hey, how do I make sure the performance of my asset is always optimal, that asset runs on an optimal performance level? How do I make sure that I should not have any unplanned downtime? And the only way GE can make that happen is by listening to what asset at the field is telling us, by getting all that data from the edge to the cloud, process it, understand the running condition of the asset and take actions accordingly. So that's the big use case we have at GE, and why we are doing all of this big data analytics, IoT, industrial IoT work. So let me just touch base upon what our relationship with the messaging and how messaging is available on our platform, which we call Predix. So we have a messaging service called Predix Message Queue. We built this service based on open source software called RabbitMQ. And primary goal of this message is to provide, for the services to provide messaging support and protocol supports like AMQP and MQTT. We run more than 3,000 brokers in production, and the way our developers are using them is broadly into two categories. One is the microservices they are using to do microservice communication, and the other is the edge to cloud. In the interest of time, I'll cover one use case out of these two, and I'll touch base upon what that use case is all about. So as Trevor also mentioned that the AMQP is getting very popular as a message protocol. There are reasons why it is getting popular. So one of the reason is, and also a use case is the rise of microservices. Now most of the applications are nowadays being developed as smaller microservice rather than one big monolith application. And AMQP protocol help you tackle the problem of communication between the microservice. So the traditional way of a microservice is talking to another microservice is using HTTP. But the most use cases I'm seeing these days is over AMQP. And what are the advantages of doing that over AMQP, over HTTP? I'll go through them quickly. The first one is application decoupling. So an application A is talking to application B on HTTP, then both are dependent on their SDK to make that call. But if they talk over a message queue using AMQP, they don't have to dependent on each other SDK. They also gives them capability to change without dependent on other one. So I can change my microservice anytime without changing the other application which are dependent on me, because all I'm doing is consuming or publishing message on the queue. You can also implement some of the advanced use cases like event-based processing. It also gives you flexibility to scale certain things in certain fashion. You can scale application A without scaling application B because you have a buffer of message queue in between. That's another big use case. One of my favorite is resiliency. And what does that mean is, if an application A is talking to application B, and application B is taking a dip or not available for 1 minute or so, then application A will face degradation. But if they are talking over a message queue or through an AMQP protocol and with the message queue in between, application A will not face a degradation because application A will continue publish messages on the queue. Queue has a buffer, and it will allow application B to recover from the outage like in 30 seconds or whatever. And as application B will resume processing from where it crashed or left off. So that's some of the use cases which we are seeing in AMQP. And Amazon MQ is the first managed AMQP support on AWS platform. So it is pretty exciting for us and everybody who is using AMQP protocol for different use cases. In this case, microservices with AMQP. It's pretty exciting that AMQP support is available in a managed way. So now let's touch base upon do-it-yourself versus the managed service. Do-it-yourself looks easy, but actually it is not. The installation is fairly simple with all the tooling, which now we have, all the packaging system we have like Docker, apt-get and all. But installation is not enough. The minute you have a software installed, you have to worry about the availability of the software. So you need to make sure you install in HA fashion. Plus, you also need to make sure that you keep it available and up and running all the time. The next challenge which I faced or we faced when we were doing this is like the features and configuration management of the software itself. So let's say if you are giving software to customer, like developer A, and also to the developer B. Now developer A wants one particular setting, developer B want another setting. They want queue size to be different. Now you need to give capability to these teams to do the changes themselves. Otherwise, you're always in the middle of them, making changes for them. Backup is equally important. You need to take the burden of backing up the configuration and the data at times. Integration to your logging and monitoring system is key. It is hard because you need to write your own monitoring checks and things like that. Security is being one of the hardest. No matter where you start, there will be vulnerabilities which you need to patch. And when you need to patch the kernel or the operating system, it's not easy. You need to change the operating system on which your software is running. You need to take an outage and in order to do that, and that's pretty hard. Maintenance is again a problem. Very soon, your version of the software which you're running will be obsolete, not being supported, or you need to upgrade. That's also you need to take into consideration. The last point which I say is the hardest for us is finding the commitment from your organization in order for you to build all of these things, plus the investment, like the financial investment it required to make it happen, and also the talent to find the people who knows the message broker plus the infrastructure equally well to make all of this happen for you. It's hard. So at the end, I would say if you want to decide whether you should do it yourself or go for a managed service, I think it's fairly simple that managed service is far better. And even if you have to take some changes into your development cycle immediately, to go to the managed service is worth the effort. For example, if you are on RabbitMQ, it's worth the effort to make some code changes in your code and start using ActiveMQ because it is available as a managed service on your platform of choice. So that's also worth, because you'll get all of this on day one without worrying about any of this. That's the benefit of managed service, and that's where I would leave you guys with. Thank you very much.
Thank you very much, Amulya. That was a really great presentation, and I appreciate you sharing your experiences with managing your own message brokers at GE. So that's the presentation for today. I encourage you to go check out our website. The URL is here, and go ahead and check it out and log in and create a broker. It just takes a few minutes, and you can play around with the service, and it's fairly easy to use and get an idea of how it works. And now we'll take some questions. Okay, so first question. Do you support automation like CloudFormation? So yes, we are integrating with CloudFormation, and we have a plan to have this in the next few months. We also have a partner, HashiCorp, which makes the Terraform service or Terraform application, and Terraform is actually integrated with Amazon MQ today. So that's another option for if you're doing any infrastructure as automation. Sorry, infrastructure as code. Next question, when will you support the London region? We are planning to support new regions this year, including London, Tokyo, Singapore, among others. And we do plan to roll it out globally over the next 2 years or so. Okay, next question. We use ActiveMQ with network of brokers. Do you support that? So as I mentioned, so you can configure network of brokers in an external ActiveMQ, like on-prem, and connect that to an Amazon MQ broker. What we don't support yet is network of brokers between Amazon MQ brokers, so creating a network or a cluster of brokers in the cloud. And that is something that's planned for the future on Amazon MQ. Okay, next question. What kind of performance do you have any benchmarks? So we have done some benchmarking. and I guess the key thing here is it really depends on your scenario. Messaging and the way ActiveMQ can be used is so many variants and different ways you can use the service and use queuing and topics and things like that. So, we really encourage you to do your own benchmarking, and we're going to publish a blog on how to do that. But we have seen in some of our tests, we've seen in persistent mode, we've seen as high as 15,000 messages per second on our larger instance sizes. So I treat that as kind of an upper number, and you should really test it and confirm yourself for your own scenario. Next question. I'm using RabbitMQ today on EC2, and how easy is it to migrate? So yeah, that's quite common. We hear quite a few customers using Rabbit today. It's fairly popular. To migrate, it depends on which APIs you're using with RabbitMQ. So if you're using JMS, like a JMS client with RabbitMQ, it's a fairly straightforward switch over, because just straight to JMS. If you're using AMQP, Rabbit supports a few different versions of AMQP. They support a pre-standard version, AMQP 0.9. They also support 1.0, which is what Amazon MQ supports. So if you're using 0.9, it might take a bit longer. You might need to make a few code changes, because it supports a concept of exchanges, which need to be mapped over to Amazon MQ. So there's a few changes, and we're actually publishing a blog with some guidance on how to migrate from RabbitMQ. So that should be coming out in the next few weeks, and we encourage you to check that out. Next question, will you offer larger instances to amp up the performance? So we are planning, we do have plans to add a variety of other instance sizes. So you should see that coming out down the road here. Let's take one more question here. So what kind of message durability does Amazon MQ provide? So by durability, I assume they mean kind of persistence and durable storage. So so with ActiveMQ, as I showed in the demo, you can use it in persistent or non-persistent mode. So in persistent mode, that's where you're going to get the message durability and resilience to failure. So in that mode, messages are redundantly stored across multiple availability zones. So in AWS regions, there's always multiple availability zones, which are physically separate facilities. And the message store can be accessed concurrently from all those AZs in the region where it's located. So that means the message broker can fail over from one AZ to another AZ without any message loss. So it's very highly durable message storage. That's one of the real advantages of using this as a managed service. Okay, so please check out our website. The URL is shown on the slide here. You can get started in a few minutes. It's quite easy to launch a broker, and it's free, as I mentioned, for the first year with the T2 micro instance size. There's also a demo on our website, so please check that out. And thank you very much.